Hello friends, welcome to our channel Piping Mantra, and today we are going to discuss about heat exchanger, that is concept or principle behind it, and we will also be briefly discussing about classification of heat exchanger on the basis of various factors. So let's get started. As we all know, transfer is one of the most important industrial processes. Throughout any industrial facility, heat must be added, removed or moved from one process stream to another. There are three basic types of heat transfer. First, convection, which is the movement of heat by actual motion of matter. Second is conduction, which is the transfer of heat energy by direct contact. And radiation, which is the transfer of energy with the help of electromagnetic waves. Out of these, the two most common forms encountered in the chemical processing industry are conduction and convection. And as the name suggests, heat exchangers are used to transfer heat from one process to another. Heat exchangers are widely used equipments in the chemical, petrochemical, and refinery type of plants. The control of heat within a plant operation is done by direct heat application in heat exchanger by convective and conductive heat. Various process duties of heat exchanger have an effect on the layout aspect. The process duties include: first, exchange of sensible heat between two process fluids like cooling of air or water, chilling with refrigerated liquid, heating with steam or hot water. Second is exchange of latent heat between two process fluids where phase change takes place like condensation by water or a cold process stream, vaporization by steam, for example column reboiler, or any heat transfer liquid. On your screen, you can see a typical flow diagram with different heat exchangers. From this, you can refer to the typical locations of air cooler, kettle type heat exchanger, reboiler, and shell and tube exchanger. The next picture shows the typical plot plan of several exchanger applications. It shows location of heat exchanger with respect to pump, rack, vertical column, drum, and structure, which will be explained in upcoming videos in detail. Now, let's move on to the classification of heat exchanger on the basis of various parameters. Now, heat exchanger can be classified on the basis of configuration of flow in heat exchangers. Let's see how. There are three types of configurations of flow in heat exchangers. First, parallel flow, where the hot fluid and the coolant flow in the same direction. Second is counter flow, where the hot fluid and the coolant flow in opposite directions. Third is cross flow, where the hot fluid and the coolant flow perpendicular. To increase the efficiency of heat exchangers, they are designed to maximize the surface area of the wall between the two fluids while minimizing resistance to fluid flow through the exchanger. The exchanger's performance can also be affected by the addition of fins or corrugations in one or both directions, which increase surface area and may channel fluid flow or induce turbulence. The second classification is based on regeneration. There are two types of heat exchangers in this category. First is regenerative heat exchangers, which uses the same fluid for heating and cooling. Second is non-regenerative heat exchangers, which use separate fluids for heating and cooling. Third is the classification based on process function. Exchangers are most frequently classified by their process functions like exchanger, which heats one stream and cools the other by means of heat transfer without mixing. Cooler, which cools liquids or gases without condensation. This concept also applies to intercooler and aftercoolers. Condenser, which condenses vapor or vapor mixture. Chiller, which uses refrigerant for cooling process stream below freezing point or below prevailing cooling water temperatures. Heater, non-fired, heats process steam generally up to its boiling point up without appreciable vaporization. Heating medium is usually steam, and the same concept also applies to preheaters. Reboilers, which reboils the bottom stream of tower for the fractionation process. Heating medium can be steam or hot process steam. When large quantities of vapor have to be produced, the kettle type reboiler is used. Waste heat boiler. It uses waste heat such as internal combustion exhaust from gas turbines and similar drivers for steam generation. Steam generator. It uses heat of processed liquid or gas for producing steam. Vaporizer. It vaporizes part of a process liquid steam, as does an evaporator. Works on the same principle as condenser but in a reverse direction. The last type in the classification based on heat exchanger construction, which is first shell and tube exchangers, second kettle type reboilers, third plate heat exchangers, fourth spiral heat exchangers, fifth double pipex, sixth air cooler exchanger. We are going to cover each one of these exchangers in separate videos for their basic components, piping layout maintenance requirements, applications and all other related details. Now, according to Tubular Exchanger Manufacturers Association TEMA, heat exchangers can be further classified into one more category on the basis of its part shape. This classification is usually applicable on shell and tube and kettle type heat exchangers. There are three types, that is front end stationary head type, rear end head type and shell part shape, which are as follows. Front end stationary head types include A. Channel and removable cover, B. Bonnet, that is integral cover, C. Removable hot tube bundle only, N. Channel integral with tube sheet and removable cover, and D. Special high pressure closure. Rear end head types include M. Fixed tube sheet like B stationary head, N. Fixed tube sheet like N stationary head, L. Fixed tube sheet like A stationary head, P. Outside packed floating head, S. Floating head with braking device, T. Pull through floating head, U. U-tube bundle, and W. Externally sealed floating tube sheet. Shell types includes E. One-pass shell, F. Two-pass shell with longitudinal baffle, G. Split flow, H. Double split flow, J. Divided flow, K. Kettle type reboiler, and X. Cross flow. In this, the alphabets used along with the pictures are of great importance as we use these to identify the type of heat exchangers to be used. Sometimes this alphabet is the only information given on data sheets. So that is it guys. I hope this video is useful. If you like this video, please hit the like button, and for more similar content, please hit the subscribe button. So see you next time with something new to learn. Till then, keep on watching and asking questions. Bye bye. Thank you.